Hello, in this video we will do this problem on limits calculus. Evaluate limit x tending to pi by 4 1 minus sine 2x divided by 1 plus cos 4x. There are two methods. Now method 1 in place of x we will put pi by 4 and simplify and see what happens. Okay, 1 minus sine pi by 2 divided by 1 plus cos pi. I put x as pi by 4, so just to put x as pi by 4, so 2 into pi by 4 is pi by 2. Got it? Cos 4, x as pi by 4, so cos pi. But we know that cos pi is minus 1. Cos pi is minus 1. Therefore, this simplifies as, which is 0 by 0, which is an indeterminate form. Okay. Therefore, what do we do? This 1 minus sine 2x we write as sin x minus cos x the whole square. That is, when you expand this, you will get sin squared x plus cos squared x, which is 1. Then minus 2 sin x cos x. 2 sin x cos x is nothing but sin 2x. So 1 minus sin 2x can be written as sin x minus cos x the whole square. Similarly, 1 plus cos 4x can be written as 2 cos squared 2x. Therefore, this can be now written like this: sin x minus cos x the whole square divided by 2 cos squared 2x. Now you substitute x as pi by 4 in both numerator and denominator. Cos pi by 4 the whole squared is again 0, because sin pi by 4 is 1 by root 2. Similarly, cos pi by 4. So again now the numerator is 0. Then what about the denominator, which is 2 cos squared 2x? Again 0, because x is pi by 4, 2x is pi by 2, so you get 0. Now also 0 divided by 0, which is an indeterminate form. Therefore, we further simplify this in a different way. Limit pi by 4. Take only the denominator. You write as it is. The denominator, cos squared 2x, can be written as cos squared x minus sin squared x the whole square. Now you try substituting x as pi by 4. Of course, we substituted already in the numerator, but denominator we will now check. Again 0, right? Cos squared pi by 4 minus sin squared pi by 4 would be 0, because cos pi by 4 is equal to sin pi by 4 is equal to 1 by root 2. So further simplify, which is an indeterminate form. So this cos squared x minus sin squared x, you can write as cos x plus sin x into cos x minus sin x, using a square minus b square is equal to a minus b into a plus b form. Okay, can be written as right. So this is similar to a squared minus b squared. Of course, whole square is there. Now this cos x minus sin x, can write as minus of sin x minus cos x. Okay, so the square has to be put here, then cos x plus sin x, the whole square has come here. Now when you simplify this, you get into cos x plus sin x the whole square. So put it in the function. So cancel sin x minus cos x the whole square both from the numerator and denominator, and you have limit extending to pi by 4, 1 by, that is 1 divided by 2 into sin x plus cos x the whole square. Okay. Now substitute x as pi by 4 and check. You get right, because sin pi by 4 is 1 by root 2. Now when you simplify this, 1 by root 2 plus 1 by root 2 is 2 by root 2. 2 by root 2 square is there, whole square is there. So this half will come as it is, 2 by root 2 square in the denominator. So you get 1 by 4. Therefore the answer is 1 by 4. Then method 2, we will use what is known as L-Hospital rule or L'Hopital rule. Second method, or method 2, you consider 1 minus sin 2x as f of x, 1 plus cos 4x as g of x. Okay. Already we found that when you directly put x as pi by 4 here, you get 0 by 0, which is an indeterminate form. In such cases, when you evaluate the limit, if you get one of the indeterminate forms, we can use what is known as L-Hospital rule or L'Hopital rule, which states like this. Suppose if you evaluate this limit, if it turns out to be one of the indeterminate forms such as 0 by 0, then we can proceed like this. So differentiates the numerator and denominator separately, not using quotient rule, and then finding the limits. Okay. For that, the condition should be this. When you evaluate the limits, you should get indeterminate form. Then only you should apply L-Hospital rule. So what is f prime x? This is f of x. So differentiate. You get 0 minus 2 cos 2x. Similarly, g prime x. This single prime will indicate first derivative. Okay. Then we get limit x tending to pi by 4 minus 2 cos 2x by minus 2 cos 2x by okay, this minus 2 divided by minus 4 is there, here. Okay, minus 2 divided by minus 4 we can take as half, right? Now you substitute in substitute x as pi by 4 in cos 2x divided by sin 4x. x is pi by 4, right? That will be same as before. So pi by 2. This also will be so pi. But cos pi by 2 0, sin pi is also 0. So you get 0 by 0 even after differentiating it for the first time. So 0 by 0. So now you have to differentiate once again. You can apply this L'Hospital rule repeatedly. So half into limit x pi by 4. How this half came? So minus 2 by minus 4 is there, you take it as half, bring it outside this limits. Which gives you an indeterminate form. Go to the differentiation once again. That is f double prime x is equal to minus 2 sin 2x. That is, you have to differentiate this. You get f double prime x. Then g double prime of x is equal to four cos 4x. So by 4 cos 4x. Now you substitute x as pi by 4. You can now check. Sin pi by 2 is 1. Cos pi is minus 1. Therefore minus 2 by minus 4, which is half. Because already one half is there here, no? So that half is written here. This half comes from this. So when you evaluate this limit, you get the final answer as 1 by 4 as before. So we can now look at the graph. This is the graph of the given function. That is 1 minus sin 2x by 1 plus cos 4x, x-axis, y-axis. When x is 0, the function gives you the value half. Then you can see pi by 4, this is 1 by 4. See, from the graph you understand that as x approaches pi by 4, the function approaches 1 by 4. That is, the value of the limit is 1 by 4. Okay, thank you.